Yes, students, this is the another topic in our transistor topic. Is NPN transistor as common emitter mode NPN transistor as a amplifier. As I said, to use this transistor as a amplifier, we must maintain the transistor in as active region. Transistor in what, children? Active region. That we discussed in the previous video. Yes, a transistor should be maintained in the active region. What, children? Active region. Yes, as I said in the previous video, in the characteristic study, very simple. As applied voltage is equal to sum of the voltage across the voltage across the input part or output part of the circuit. So now I am going to write the voltage equations in what, children? Input and output part. Yes, so you just take the input part and this is what, children? Output part. The main purpose of the amplifier is to increase the amplitude of the amplitude in the sense voltage or current of the weakly input signal. We know that mic is used, the audio signal is converted. Mic will convert this sound wave as to be electrical signal. That means current or voltage. That will be as given to the big block color box. We know that is called amplifier. Yes, which will increase the strength of the what, children? This is audio signal. Strength of the audio signal means their voltage will be increases as well as current also will be gets increases. Okay, children. So that is called this is called output signal and this is called input signal. So mostly our that voice or music, everything will be sinusoidal in nature. Yes, we know that since our transistor is functioning only under the as a pure DC currents. That's why I am using as input capacitor and output capacitor. You know that if when this input signal is crosses this region, you know very well that in AC chapter we learned that XC is equal to what, children? 1 by C omega. For DC current, what, children? So for DC current, that will be omega will be 0. So we know that XC is equal to 1 by C omega. For or same can be written as 2 pi f also. For DC, frequency will be 0. So therefore XC will infinity. XC will what, children? Infinity. That means when this audio signal, which is converted as the electrical signal by mic, now if it contains any DC component, that will be completely stopped by this input. What is that? Capacitance. Input what, children? Capacitance, because the reactance value for or impedance value for or reactance value of capacitance for DC as a component will be infinity, as we said. Yes. Now if now the input signal is given to the this audio, the signal as the sinusoidal weak signal, which one we have to be amplify is given to the input part of the circuit. If this contains any DC component, that will be stopped by the input capacitance. So when it crosses this point, which is contains only the pure sinusoidal signal, the signal in the sense of voltage. Okay. What will happen when that when the voltage change, there will be a corresponding change in the input. What is that? Voltage is biased in the transistor, and that will be whatever change happen in the input part, that will be reflected in the output part. That explanation we are going to give, but I am just telling that what will happen, why this input capacitance and output capacitance are used. Similarly, output capacitance, if the signal contains any DC component, that will be completely stopped by this output capacitance only. The sinusoidal varying output will be getting us to be what, children? Output with a slight phase change. What is the reason for phase change? That and all we will be discussed. Okay. Now as we said, applied voltage is equal to sum of the voltage across the remaining part of the circuit. That simple logic and Ohm's law alone I am going to use here. So input part, I am taking the case 1. Suppose this circuit is not connected in the circuit. That means there is no what, children? Input signal. That is this sinusoidal wave or voltage is not given here. That I consider V in has to be 0. First case I can consider what, children? If V in has to be 0. If V in has to be what, children? 0. That means the signal is not given. then what will happen? This branch is no need to consider. This branch is no need to consider, only this part will be there. What I said, applied voltage is equal to sum of the voltage across the remaining part of the input circuit. So therefore I can say that is VBB, that is applied voltage, biasing voltage, that is equal to what, children? Is IBRB, that is base resistance, plus VBE, plus what, children? VB. Similarly, in the case 1 in output part also, when as input signal is not given in the circuit part, then I can say that is the output, yes, this is the applied voltage. Applied voltage equal to sum of the voltage across the, yes, what, children? The collector resistance. This collector resistance sometimes is called load resistance. Load resistance. Okay, children. But here I am going to use only RC as the symbol. So this applied voltage in the reverse output part of the circuit is VCC, that is equal to what, children? ICRC plus, yes, what, children? VCE plus what, children? VCE. Yes, we know that VCE and all we already discussed. Yes, this part is called what, children? This potential difference between collector and emitter is called what, children? VCE. This part will be VCE. So applied voltage equal to sum of the voltage across the remaining part of the, yes, what, children? Output part, when this input signal is considered to be 0. That means if this is 0, then this part is ineffective in the circuit. So only this branch or this part of the circuit only is exist or active in the circuit. Okay. Now I am going to discuss about the second part of the circuit. Now I am allowing or I am supplying this as a sinusoidal input signal. That means if Vin is not equal to 0, that means this part of the circuit is included. What is the nature of the voltage as delivered by this input signal? Sinusoidal voltage. So for example, if we consider the maximum voltage, biasing voltage is for example plus 10 volt, for example here VBB, say this, since this is the weak signal, this is taken as to be plus 1, this is taken as to be what, children? Minus 1, the maximum and minimum values. When during the first off cycle, what will happen, children? This is the positive potential, here also positive potential, for example plus 10 volt. So plus 10 plus 1, that is 11 volt. So the input voltage previously, when Vin is 0, it is still 10 volt only. Once the input signal is added, the biasing voltage changes not as a constant, it will be changes, for example plus 1 and plus 10, 11. Now when the input signal going to the negative cycle, the voltage will be minus 1, but this will be what, children? We are assuming for understanding purpose has to be plus 10. Therefore plus 10 minus 1 will be 9 volt. So when input signal is not connected, the applied biasing voltage remains constant. When the input signal is connected in the circuit, the biasing voltage will increases like 11 volt, 9 volt sinusoidally or periodically by corresponding change in the input signal. Okay. So therefore, in that case, I can write this as VBB. That VBB is mixed with what, children? Input, what is that? A signal, a sinusoidal as voltage. I can call it as that has to be Vin. That has to be what, children? Vin. So that is equal to, as I said, applied voltage is equal to sum of the voltage across the remaining part of the circuit. Therefore, IBRB plus VBE. Yes, this is the, yes, what, children? As the original voltage as input has to be 0, input signal has to be 0. Since in the biasing voltage is mixed with some input signal, because of this additional term, there will be a additional term here also, that is delta IB, that is a voltage, current into resistance, RB plus what, children? Rin. RB plus what, children? Rin. What is this Rin? Means this circuit, as this input signal is nothing but that may be a electronics or electrical circuit which may have some resistance, that is taken as to be as a signal resistance Rin. Signal resistance what, children? Rin. So this is the term. Yes. Now take this has to be equation number 1 and this is equation number 2. Just do as a 2 minus 1, children. Just do 2 minus 1. Therefore I can get that as Vin, that is equal to what, children? Yes, delta IB. What, children? Delta IB is RB plus small r in. This resistance together, this series resistance together, I can consider that has to be a small r, the total input resistance in the input part of the circuit. So I can consider this has to be what, children? R. This has to be some resistance R. Therefore, I can write that as V in is equal to what, children? Delta IB into small r. This small r is nothing but this term. So this is what, children? Input voltage equation. Say for example equation number 3. Equation number what, children? Yes, 3. Okay. Yes. So equation number 3. Equation number 3. Now please come to the output part. The second case is as we said here. If input is mixed in the input part of the signal, yes, that the signal voltage is mixed with the input part of the signal, then what, children? When V in is not equal to 0. When V in is not equal to 0, I said that whatever change happening in the input part, that will be reflects in the output part. Therefore, since due to the addition of the signal voltage with the biasing voltage in the input part, that will make the change in the output part. So that corresponding change, as I said, differentiate it, change. The constant biasing voltage whose differentiation is 0. Constant differentiation means what, children? Is 0. So therefore we can say that 0, that is equal to delta IC RC plus delta VCE plus what, children? Delta VCE. So this delta VCE is considered to be output voltage. This delta VCE considers to be what, children? Output voltage. Therefore I can say that V out equal to what, children? As minus delta IC RC. Minus delta IC what, children? RC. So therefore I can take this as to be equation number 4. And this will, equation number 4 is differentiated. Now I can get this as to be equation number 5. Yes, these are the explanation about how the voltage equations should be written for the amplifier when the input weak signal, sinusoidal signal is mixed with the input biasing voltage, and what will happen, the corresponding change in the output part. Yes. Now please see that, children, what are the parameters I am going to define hereafter means, the first one, that is called voltage gain. That is called what, children? Voltage gain of the amplifier. So AV, A means amplification, V means voltage amplification. AV, or simply we can call it as voltage gain. You know that voltage gain, generally gain means what, with children? Here we said output by input part. Therefore I can say that AV is equal to S V out divided by S V in, that is equal to S V in what, children? Delta IB small r. So therefore, V out is minus delta IC into RC divided by V in what, children? Delta IB into small r. Suppose I am assuming that, yes, here, so where what, children? Small r is equal to what? RB plus Rin, that is base resistance plus resistance of the signal circuit. Generally, when compared to this base resistance, Rin is what, children? Less or negligible. Less or what, children? Negligible. Therefore, small r can be written as to be capital RB. That is like this. So by using this condition, we can write that as what, children? AV, that is equal to as V out by as V in, that is equal to this small r is replaced by RB, and moreover we know that as delta IB by delta IC by delta IB is nothing but beta AC. So therefore I can write that as that has to be minus delta IC by delta what, children? IB into RC by what, children? RB. This is one of the expression as RC by RB. So that is equal to minus beta into what, children? RC by RB, because delta IC by delta IB equal to what, children? Beta, and RC by RB. RC by what, children? RB as written. So this is the equation for what, children? Yes, what, children? Voltage gain. What, children? Voltage gain. Yes. Please kindly note down the theory part, students. Yes. the second parameter what we are going to define is current gain of the amplifier. Current gain, we already discussed what is current gain formula in CE mode NPN transistor. So beta, that is equal to what, children? Current gain, or simply I can call it as beta AC, that is delta IC divided by what, children? Delta IB, that we know that. As the third one what I am going to write is as power gain of the transistor amplifier. Power gain of the transistor amplifier. So power gain, or I can say that AP, that is power amplification. Generally electric power means what, children? Voltage into current. Since I am talking about gain, therefore voltage gain into current gain. So power gain is equal to what, children? Voltage gain into current gain. So therefore here I can write that as AC. As AB we already written that as AB is equal to what, children? Minus beta AC. Since delta is there, I can say already that this is AC. Therefore I can say that minus beta AC RC by RB. This is AV value into what, children? Yes, what is the remaining term here? That is beta AC. So therefore the power gain or the amplification of the power can be written as to be minus beta square AC, what, children? Yes, that is RC by RB. RC by what, children? RB. Sometimes this RC, sometimes it call it as to be load resistance. But whatever may be that, this is the output resistance and this will be input resistance part. Okay, children? Yes. So what is the significance of these negative signs are? Yes, this negative sign indicates as what, children? This negative sign indicates there is a what, children? There is a 180-degree phase difference, or we can say that pi radian. 180 degrees phase difference or pi radian phase difference. What is that? There is a 180 degree or pi radian phase difference. Yes, phase difference between what, children? Between input and output voltages. Between input and what, children? Yes, output voltage. Output what, children? Voltage. We know that in a sinusoidal wave, as in AC lesson we studied that. For example, for understanding purpose I am telling that in AC lesson we studied that E equal to E naught sin omega t, or simply we can say that V is equal to V naught sin omega t. Whatever may be that, after this trigonometric function, whatever is there, that is called a phase vector, and this is called amplitude. That is that and all you know that. So this negative sign represents what, children? As there is a phase difference between input and output voltage. That's why in the circuit diagram, when the input has to be in the positive cycle is like this, the output diagram we drawn in this manner. Yes, this will be negative and positive. Since the value is amplified, the peak value will be maximum for output voltage. So that is the reason for this indication of this negative sign in this part of the what, children? As amplifier circuit. Okay. Yes. Now please see that how this 180-degree phase difference can be understandable. Yes, that means I can say that is D. Explanation for what, children? Yes, 180-degree phase difference. 180-degree what, children? Phase difference. Yes, it's very simple, children. You just take this input as equation. So when input increases, corresponding as IB value also increases. Yes, obviously. But you just see this relation. As we studied earlier that when input voltage increases, corresponding input current also will be, when input voltage increases, input current also increases. When input current increases, there will be a increase in output current. We know the transfer characteristics of the a transistor. So when input voltage increases, input current IB also will increase. Therefore IC also will be increases. But this is with what sign, children? Negative sign. Therefore Yes, when this value will be yes increases, the value of V out will be decreases because of the negative sign. As I said earlier, -1, -5, which is lesser value means -5 will be lesser when compared to -1. So in that sense, you have to take this explanation. So when input voltage increases, input current increases, which increase the corresponding voltage value of the output current, but there is a negative sign, therefore I can say that value of V out decreases. So when V in increases, the value of V out will be decreases, children. So that's why I can say that in that manner as what children, as what V in increases, there will be a corresponding increase in IC value. There is a corresponding increase in what children? IC value, because IB, IC are interrelated. When IC increases with the negative sign, the value of V out is considered to be as decreases, because in negative number, as large number has lesser value. Yes, therefore V out will be what children? Decreases. So therefore when input increases, output will be decreases. That's why when input is in positive cycle, when input is in what children? Positive cycle, the corresponding output will be in negative cycle. But you see that V out equal to what children? V out equal to A times of AV times of V in. AV times of V in. That means V out is, whose magnitude is this much times of V in. Therefore the output voltage will be amplified. That's why this peak value will be more. So this will be negative cycle and positive cycle. So the peak value will be less for the input signal, but here it will be as a maximum. So that means the voltage value or current value, which is given as to be a weak sinusoidal signal, it can be increased or amplified. Yes. So this is the complete explanation about what children? Transistor, NPN transistor in CE mode as a amplifier. In CE mode as a what children? Amplifier. As I said, we have to maintain transistor in active region. Yes, children. So I hope that you may get the clear understanding about the transistor functioning, transistor basics, transistor characteristics, and transistor as a switch and transistor as a amplifier. Yes, very simple. The idea to solve such type of circuit related is what children? Yes, questions. You just memorize the important standard results, that is power gain, voltage gain, current gain, and this voltage equation on what basis we have written. But the very simple idea so far what I discussed is only Ohm's law, and the simple logic is what children? The applied voltage is equal to sum of the voltage across the remaining part of the circuit, and we know that what is knee voltage or cut-in voltage during the forward bias of the junction diode. Yes, I hope that the basics of the junction diodes are as you know very well. Yes. So thank you students. These are the complete information about your transistor basics and transistor characteristics and transistor as a devices. Yes. I think the oscillator part is not in our syllabus, so I hope you no need to bother about transistor as a oscillator. Yes, okay children, thank you, please kindly note it down.